All right, so we're ready for step 2, but let's go grab our expression from step 1 because we're going to need it. So let's just copy and paste that over. And so basically what we need to do in step 2 is we need to define Laplace transform currents or voltages corresponding to the time domain currents and voltages. So in this case, all that we care about, like I said, is I of t. So our definition here is just going to be that this I of t has some equivalent I of s in the s domain. And that's really all we do for that first step, is just say, okay, so in the time domain, this is the variable that I'm interested in. In the s domain, it's going to be this variable or this function. Okay? And so that's step 1. Step 2 says transform the equation or equations into the s domain. And so what that means is that we now need to go term by term and transform this into the s domain. So let's take a look at how we can do that. So the first one is VO times U of t, okay? So when we transform that into the s domain, we need to take a look at the Laplace transform table. So what does the Laplace transform table tell us? It tells us that U of t, or a constant, has a Laplace transform of 1 over s, right? So if that's the case, and we also know the transform property that multiplication by a constant in the time domain results in multiplication by that same constant in the s domain. So we can go back, and for this first term, we can just say that it's going to be V out times, or V0 times 1 over s. Okay, so that's our first term there. Okay, so the second term is I of t times r. Again, multiplication by a constant doesn't change anything. So in the s domain, this is just going to be equal to I of s multiplied by r. Okay, so those two are pretty straightforward. A couple of these other ones are going to get a little bit more difficult to look at. Let's look at the next one, which is minus 1 over c times the integral from 0 to t of I of t dt, right? And so this is the time integration property. We need to take a look at the time integration property. We basically said that if we take the integral, right, let's go back to the properties table. If we take the integral of our function in the time domain, we need to divide by s in the s domain, okay? It's not 1 over s, right? That's 1 over s is the transform of u of t. We're saying that if we take our function and integrate it, this would be our I of t here, this would be our I of s. We need to multiply our I of s by 1 over s. And then, of course, we have a constant as well, so we need to bring that constant with us because we have a 1 over c there as well. So we bring the 1 over c with us, right? But then we also have to divide by s and multiply that 1 over s by I of s. And so this is our term for this integral. Next, we have the constant, which is the initial condition Vc of 0 minus. That's going to be a constant term, which just needs to be divided by s. So we could say Vc of 0 minus divided by s. And then the last expression here is the derivative term, which is L di of t times dt. Of course, we have a constant out here, but let's go look at our time differentiation property. Our time differentiation property is right here. It says that we need to multiply I of s by s and then subtract the initial condition for our function, which in this case is I of 0 minus. So let's go do that. Sorry, wrong one. So this is going to be multiplied by L, of course, because our constant comes along for the ride. S times I of s, and then minus I of 0 minus, which is the initial current in the circuit. And so lastly, let me just comment on the fact that this problem in the textbook, this is on page, let's see, this is section 12.4 on page 641. It does say, let's assume that this circuit starts with no stored energy, which basically means the initial condition on the capacitor is 0 and the initial condition on the current through the inductor is also 0. And so we can send both of those terms to 0, and our final equation here in the s domain is going to be VO over s equals IS times R minus IS over SC plus SL times I of S equals 0. Or sorry, not equals 0. That's the expression right there. And so you can see already how we basically just converted a very difficult integral differential equation into a very easy to solve algebraic equation, right? We can now factor an I of S out of this and pull an R, a minus 1 over SC, and SL. And what do we have? We just have a really easy circuit to solve for I of S. It's really not going to be that difficult. And then that's going to be what we do in step 3. And in step 4, it's going to be transforming this thing back to the time domain, okay? So I'll end this video here. If you have any questions, obviously feel free to let me know. But really what we're doing here is just taking the transform, the Laplace transform of each individual term, putting it into the S domain, of course, and then rewriting the expression. We let our initial conditions be 0 per the textbook's description of the problem, and we end up with this expression. So this is our goal for the end of step 2, is to transform the equation to the S domain, and that's exactly what we've done. All right, so I'm going to end this video here, and we'll see you guys in the next video for step 3.